Hello and welcome back. So in this video we are going to discuss a few past paper questions from IGCSE maths about sequences and patterns. So the first question over here, it is taken from May-June 2025 paper 4 variant 1 and it is question 5 of that paper. Its A part states these are the first 5 terms of a sequence 1, 8, 27, 64, 125. Find the 10th term of this sequence. So as we can see that it is basically a cubic sequence, as 1 is basically 1 cube, 8 is 2 cube, 27 is a 3 cube, 64 is the 4 cube, and 125 is the 5 cube. So basically its nth term shall become n to the power 3, and as we need 10th term, so it will be 10 to the power 3, and 10 to the power 3 equals 1000. So that is the 10th term of this sequence. That was A part. Now in B part it states these are the first 5 terms of a different sequence. The terms are 5, 8, 13, 20 and 29. Find the nth term of this sequence. So as we can see that it is a sequence with terms 5, 8, 13, 20 and 29. So first we will take the find the difference sequence. 8 minus 5 is 3, then 13 minus 8 is 5, 20 minus 13 is 7, and 29 minus 20 is 9. So we can see that first difference sequence is a not constant. So we will find the second difference sequence, which is a constant number 2. So it represents a quadratic sequence. So in case of a quadratic sequence, in order to find the nth term, I will use the formula for that: a plus d1 times n minus 1 plus d2 divided by 2 times n minus 1 into n minus 2. That is one formula for the nth term of a quadratic sequence. Here a is the first term of sequence, d1 is the first term of first difference sequence 3, and d2 is the second difference sequence, and that is 2. So just replacing these values, it will become 5 plus 3 times n minus 1 plus d2 is 2, so 2 divided by 2 times n minus 1 into n minus 2, and if we multiply it shall become n square minus 3n plus 2. So 2 is cancelled out and we are left with 5 plus 3n minus 3 plus n square minus 3n plus 2. So after we cancel 3n, we are left with n square minus positive 4. So that is the nth term of sequence given in part B. It was a quadratic sequence, so we used formula for nth term of a quadratic sequence. Now coming to C part, where it states the sum of first n terms of another sequence is n by 2 times 5n minus 1. Use n is equal to 2 to find the sum of first two terms of sequence. So we are to replace n with 2 only. So I will represent it with s2 because it is basically sum. So 2 divided by 2 times 5 into 2, then minus 1, and when we simplify it shall become 10 minus 1, which is 9. So first the sum of first two terms of some sequence, it is 9. Find the third term of this sequence. So in order to find the third term of this sequence, we shall actually subtract the sum of three terms and sum of two terms. So in order to find the sum of three terms, we replace n with 3. So it becomes 3 upon 2 times 5 times 3, it becomes 15. 15 minus 1. And we know the value of S2, the sum of first two terms, is 9. So when we simplify it, 15 minus 1 is 14. And when we divide it with 2, it is 7. So 7, 3, it is 21. 21 minus 9, so that shall become the third term, which is 12 over here. So 12 must be the third term of this sequence. So we used the formula for sum in order to calculate the third term, because if we calculate the sum of three terms and subtract the sum of first two terms, it will definitely become the third term of that sequence. Now move to the another question. So this is question from May June 2025, paper 4, variant 3, and question number 11 of that paper. It states the table shows three sequences, sequence A, sequence B, and sequence C. If we see the sequence A, its terms are 28, 22, 16, 10, and 4. We can see that it is a decreasing sequence, and we have to figure the sixth term of this sequence and nth term for that sequence. So in order to figure out the sixth term of this sequence, first find its term to term rule. As we can see, when we subtract 6 from 28, it becomes 22, and same is the difference of 16 and 22, and so on. So as it is a linear sequence, so the term after 4 shall be 4 minus 6, and that becomes minus 2. So minus 2 is the sixth term of this sequence. As we can see, the first difference is a constant number, so it is a linear sequence, and in order to find the nth term of this sequence, we will use formula for the nth term of a linear sequence. It is a plus d times n minus 1, where a was the first term, it is 28 over here, and d is minus 6, the common difference, times n minus 1, and when I simplify, it will be 28 minus 6n plus 6. So after simplification, it shall become 34 minus 6n. So that is the nth term of sequence A. Now we move to the sequence B. As we see, the first term of the sequence is 1 upon 6. The second term is 2 upon 7. The third term is 3 upon 8. The fourth term is 4 upon 9. And the fifth term looks a little different. It is 1 upon 2. But I can also write it as 5 upon 10, because that will help us to find the next term and the nth term of this sequence. Now, if we see the numerator of this one, it is basically 1, 2, 3, 4, and 5, and the sixth term shall be 6. Now come to the denominator. As we can see, denominator is also a natural number, 6, 7, 8, 9, 10. So the next number should be 11. So 6 upon 11 is the sixth term of that sequence. Now in order to find the nth term of this sequence, we will first see that it is a fractional sequence. So we will deal with the numerator and denominator separately. So we can see the sequence in the numerator is 1, 2, 3, 4, 5, and so on. So its nth term is simply n, because it is actually a natural number sequence. And the second, the denominator is 6, 7, 8, 9, 10. As we see, these are also natural numbers starting from 6. So I can write 6 as 1 plus 5. So the nth term of this will be n plus 5, because they are the consecutive numbers. 6, 7 is 2 plus 5, 8 is 3 plus 5, and so on. So nth term will be n plus 5. So the nth term of the sequence B shall become n divided by n plus 5, because we dealt with the numerator and denominator separately, and when writing the nth term for that sequence, we will write it as numerator and denominator, n upon n plus 5. That is the nth term for that sequence. Now coming to the next sequence, where the first term is 1 upon 4, the second term is 1 upon 2, the third term is 1, then it is 2 and 4. And if we observe clearly, the term to term rule for this sequence is multiply by 2, because when we multiply 1 upon 4 by 2, it becomes 1 upon 2 after cancellation. When we multiply 1 upon 2 with 2, it becomes 1, When we multiply it with 2, it becomes 2, and so on. So the term after 4 shall be 4 multiplied to 2, and that is 8. So 8 is the sixth term of this sequence. And as we see, the sequence is the term to term rule for this sequence is multiply by 2. So it is a geometric sequence or an exponential sequence. And nth term for a geometric sequence is a multiplied to r to the power n minus 1, where r is the common ratio, which is 2 over here, the number multiplied, and a is the first term, which is 1 upon 4. So it will be 1 upon 4 times 2 to the power n minus 1. Now we cannot leave it here because we need simplification for this. 1 upon 4 can be written as 1 upon 2 square multiplied to 2 to the power n minus 1. So when we will invert 1 upon 2, its power shall become negative. So I can write it as 2 to the power minus 2 multiplied 2 to the power n minus 1. Now here we have the same base. So it will become 2 to the power minus 2 plus n minus 1. As the numbers are multiplied with the same base, the powers shall add up, and the result of this sequence, nth term for this sequence, becomes n minus 3. 2 to the power n minus 3 is the nth term for the sequence C. So this was another question from IGCSE past papers. So in next video, we will try a few more questions from IGCSE past papers, and then we will move to some other topic.